Hello everyone, and welcome to our first day to talk about acids and bases. So we've talked a little bit about structures and properties of chemicals. Now we're actually going to start talking about reactions, so super exciting day. So the first thing that we want to understand is definitions. What is an acid? What is a base? Most people try to understand these based on the Bronsted acid-base definitions, and these are based around a proton. So as you can see here, a proton is just an H+. So we know that hydrogen has only one electron normally if you look on the periodic table. So if you take away one electron, all you have left is a proton. You don't have any electrons left, so that's why people call it that. So if we're looking at the H+, by definition, an acid is going to lose an H+. The base then has to do the opposite, right? If one of them is losing, the other one has to gain the H+. So that's a base. So the next skill that we really need is to know how to recognize an acid or a base when it's in a reaction. So if we look at the reaction shown for example 1, we have HCl plus NaOH. If we're identifying the acid and the base, those are always going to be reactants. So we're never going to be looking at the products for this part of the problem. So if you look at these, right now we just have to go out with our gut. So probably you recognize one of these. So which one looks like an acid to you? Hopefully you said HCl. That's hydrochloric acid. You've probably seen it a lot. If HCl is the acid, that means that sodium hydroxide is the base. So one way that you can figure out the acid and the base is just to memorize popular acids and bases, and I will show you which ones you have to know. But there's actually another way that you can figure this out if the products are given. So let's look a little bit more closely at the reaction. Both the acid and the base have something called a conjugate, something that's over on the product side. So that's something we're going to look at a little more closely. This will go back to the definition where I said an acid loses a proton. It's actually donating a proton, right? It's donating a proton to the base, and the base is going to accept the proton that the acid gave it. So it's like a trade-off, and that's what we'll see with the conjugates. So let's talk about conjugates. A conjugate base is the most important one that we'll see. This is the product that's formed when an acid loses the proton. That means that the conjugate acid must be what happens when the base gains a proton. The naming does seem a little bit switched, but it really does make sense when you look at it. When an acid loses a H+, that means it becomes more negative. So negative things tend to be bases. And that could be either a regular base or a conjugate base. Then conversely, if negative things are usually bases, acids tend to be positive. So if it's an acid or a conjugate acid, it will usually be either a positive or a neutral charge. So this makes sense because a base gaining an H+ should become more positive. So they call the product a conjugate acid because it's more positive. Let's go back to our previous example and see if now we can label the conjugate base and conjugate acid as well as the acid and base. So remember, we had already decided that our acid was going to be HCl and that our base was sodium hydroxide. So now if we look at what happens to those, we can put them in pairs, and that's probably the easiest way to recognize what's going on. So if we look at the HCl, which product matches that HCl? Well, it's losing an H+. So that means if we take H+ and Cl-, we take away the H+, what do we have left over? It's a Cl-. So if you look at the product side, we have a Cl- there. It's just hidden by the sodium. Remember that sodium plus is really just a way of covering up a charge because the plus and the minus counteract each other. So for this purpose, we don't really need that sodium there. For organics, some people show the counter ions and some people don't. So usually I will not show the metals because they're just counter ions, but sometimes your book or examples on sapling might, so we're just showing that right now. This means that the HCl and sodium chloride are linked. Because it comes from the acid, that means the sodium chloride has to be the conjugate base. Remember that the conjugate base and conjugate acid are always going to be products. But the acid and base are always going to be reactants. So we've identified the conjugate base. We'll do the same thing to figure out the conjugate acid. So we'll start with the base. What looks like the base? So let's split it up, and we see it is sodium plus an OH minus. Remember, we said that sodium is really just hiding the charge of the OH minus. And often in organic, I'll just show you the OH minus itself. I won't show you the sodium at all. So don't let that throw you. The OH minus is going to be our base. And then when it adds an H plus, what does that match? Obviously, it has to be the water since that's the only thing left over. So let's make that pair. And then we'll label the water as the conjugate acid because it's the product of the base. While you don't have to show it, you can see that by adding the OH minus with the H plus, that's how you're getting the water. It's just forming the molecule of water when they go together. This whole process also gives us another way to recognize what's the acid and what's the base. By using these relationships, we can see what's happening. So the HCl is losing a hydrogen to come over here and form the NaCl minus, and the OH is gaining an H. So we can use that relationship if we don't recognize the acid or the base that we see, if we're given the products. Let's use what we've just learned from a probably more familiar example to see if we can apply it to something new. So for this example, you may not recognize all the reagents and products, but let's use what we've already learned to try to figure it out. So the first step is we want to try to identify the acid and base if we can. So let's look at what we know. We know that the acid and the base are going to be reactants, so we might recognize water. Water, however, is tricky. It can be an acid or a base, so we're going to have to look at the other reactant. So if we look at the other one, this is a carboxylic acid. We're going to learn more about functional groups very soon, but for right now, you can just trust me. So if you see anything with that functional group, it's always going to be an acid. So we can recognize that one as the acid. Of course, if you didn't know that, you can still figure it out based on the relationship, and we'll see how that one matches with the pair. So if that is the acid, that means that water has to be the base. We can look and see if that's the case whenever we look at the relationships. So now let's try to identify the conjugate base and the conjugate acid. So remember, we're looking for products when we're looking for the conjugate base and the conjugate acid. So if we look at the product side, what matches something from the left? The most obvious one is probably what matches the acid. If we take the acid and take off an H+, it's always going to be this H+ that comes off. So if we look, the piece that matches that is obviously going to be this thing here. So we'll label this as the conjugate base. If we look also, this conjugate base has a negative charge, and that's something we would expect to see from a base, so that matches up. And again, if you either can't identify the acid and base or you're not sure, you can always check it this way. So by looking at which molecule, pairing them up first, and which one loses the hydrogen, that will show you which one's the acid. The next thing we want to match is the conjugate acid. So we're going to take the base, and that's going to gain an H+, correct? So we're going to take it and then match these together. And so that's going to be the conjugate acid because it comes from the base. Also, notice this one has a positive charge, and that's, again, something we would expect from an acid or a conjugate acid, so that also matches up. So we can see from the relationships that we've done it correctly and we've gotten the correct answer. So now that we've kind of figured out how acids and bases react together, the next step is how would we draw the conjugate base or the conjugate acid, giving only the structure or the formula. So we'll talk about that in the next video. It just was a little bit too long to fit into this one. So hope to see you soon. Thanks.